Hi students, welcome to the Maths class. In the previous section, we have studied the rationalization of denominator. I hope that you practice that well. In this section, we will study about the laws of exponents for real numbers. In our earlier classes, we already studied the laws of exponents for natural numbers. Now we are extending that to the rational exponent or fractional exponent. So let us recall that laws of exponents what we studied in the earlier classes. We know that a raised to m into a raised to n is equal to a raised to m plus n, where m and n are integers. That is the first law we studied. A raised to m into a raised to n is equal to a raised to m plus n. For example, 2 raised to 3 into 2 raised to 5 is equal to 2 raised to 3 plus 5, which is equal to 2 raised to 8. And the second law is a raised to m divided by a raised to n is equal to a raised to m minus n. That means 2 raised to 4 divided by 2 raised to 1 is equal to 2 raised to 4 minus 1, which is equal to 2 raised to 3. And the third law is a raised to m whole raised to n, which is equal to a raised to m into n. For example, 5 raised to 2 whole raised to 3 is equal to 5 raised to 2 into 3, which is equal to 5 raised to 6. And the fourth law is a raised to m into b raised to m. In the first three cases, the base are same. The fourth one, you can see that the base are different, but the exponents are same. So, a raised to m into b raised to m is equal to ab whole raised to m. A into b whole raised to m. For example, 2 raised to 3 into 3 raised to 3 is equal to, base are different, exponents are same. 2 into 3 whole raised to 3, which is equal to 6 raised to 3. And same way, the next one is a raised to m divided by b raised to m is equal to a by b whole raised to m. For example, 4 raised to 8 divided by 3 raised to 8, which is equal to 4 divided by 3 whole raised to 8. The another one is, the sixth identity is a raised to 0, that is equal to 1. A raised to 0, which is always equal to 1. Also, we have studied in the 8th standard when the exponent is a negative integer. See, a raised to minus m. Last year we have studied a raised to minus m is equal to, here the exponent is a negative integer. When it is negative integer, a raised to minus m is equal to 1 by a raised to m. And also we know, if a by b whole raised to minus m is equal to b by a whole raised to m. So these two laws we have studied last year. And this one you are getting from this law. A raised to minus n is equal to 1 by a raised to m. From this we are deriving a by b whole raised to minus n is equal to b by a whole raised to m. Now we can extend this to the rational numbers. Before that, we can see a few more examples related to these two laws. For example, 17 square into 17 raised to minus 5, which is equal to 17 raised to 2 plus minus 5, which is equal to 17 raised to minus 3. 2 plus minus 5 is equal to minus 3, which is equal, it is in the form of a raised to minus 1, that is equal to 1 by a raised to n. That means 1 by 17 raised to 3. That is the answer. And next one is 5 square whole raised to minus 7. So it will be equal to a raised, it will be in the form of a raised to m into whole, a raised to m whole raised to n, which is equal to a raised to m into n. So 5 raised to 2 into minus 7, which is equal to 5 raised to minus 14. That is equal to 1 by 5 raised to 14. Suppose, how do you compute this type of exponents? Suppose the exponents are extended to the rational numbers. How can we compute this? Even when the base are real numbers, positive real numbers, and the exponents are rational numbers, we can compute using the laws of exponents what we have studied earlier. For example, it will be in the form of a raised to m into a raised to n. No, we know the law a raised to m plus n. That means 2 raised to 2 by 3 plus 1 by 3, m plus n, which is equal to 2 raised to, the denominators are same, so you can add directly 2 plus 1, 3 by 3, that is equal to 2 raised to 1. And the next case, second question also, here also the exponent is a rational number. But you can use the law what we have studied. It will be in the form of a raised to m whole raised to n. That will be equal to a raised to m into n. So 3 raised to 1 by 5 into 4, which is equal to 3 raised to 4 by 5. So what is this 3 raised to 4 by 5? What is the meaning of that 3 raised to 4 by 5? When the exponent is a rational number, first of all we want to know what is the meaning of this. How can you express this 3 raised to 4 by 5? To understand this, we have to do some work. See, we know that in the earlier section we have discussed nth root of a is equal to b if b raised to n is equal to a. Let a be a real number and n is a positive integer, then nth root of a is equal to b if b raised to n is equal to a. In the language of exponents, nth root of a, we can write it as a raised to 1 by n. Nth root of a is equal to a raised to 1 by n. In the language of exponents, we will write nth root of a is equal to a raised to 1 by n. Suppose, for example, cube root of 2, that is nth root. It is in the form of nth root of a. Nth root of a, we can write it as a raised to 1 by n. Similarly, cube root of 2 means 2 raised to 1 by 3. Cube root of 2 is equal to 2 raised to 1 by 3. Square root of 5, which is equal to 5 raised to 1 by 2. Cube root of 27, we can write it as 27 1 by 3. 27 raised to 1 by 3. So nth root of a is equal to a raised to 1 by n. So using this, we can write this 3 raised to 4 by 5. We can write it as 3 raised to 4 into 1 by 5. 4 by 5, we can write it as 4 into 1 by 5. That means 3 raised to 4 whole raised to 1 by 5. A raised to m whole raised to n is equal to a raised to m into n. So this we can write it in this form. Now already we know that a raised to 1 by n is equal to nth root of a. So a raised, it will be in the form of a raised to 1 by n. So using this we can write it as fifth root of 3 raised to 4. Similarly, 4 raised to 3 by 2. Another example. 4 raised to 3 by 2. Here 3 by 2 is a rational number. This we can write it as 4 raised to 3 into 1 by 2. That is equal to 4 raised to 3 whole raised to 1 by 2. That we can write it as, it's a 1 by 2 means here 4 square root of 4 raised to 3. Square root of 4 raised to 3, which is equal to square root of 4 raised to 3 is equal to 64. Square root of 64 is equal to 8. Same way, this we can write it in another way also. Instead of writing this way, this we can write it as, here 4 raised to 3 into 1 by 2, we can write it as 4 raised to 1 by 2 whole raised to 3. This way also we can write a raised to m whole raised to n is equal to a raised to m into n. So instead of writing this, we can write this way also, 4 raised to 1 by 2 whole raised to 3, which is equal to square root of 4. 4 raised to 1 by 2, a raised to 1 by n, we can write it as nth root of a. So 4 raised to 1 by 2, we can write it as square root of 4 whole raised to 3, which is equal to square root of 4 is 2. 2 whole cube. 2 raised to 3 is equal to 8. In both the case, the same answer we got. So 4 raised to 3 by 2 means 4 raised to 3 into 1 by 2, that we can extend in this way. So we are using here nth root of a is equal to a raised to 1 by n. Let's see one more example. 2 raised to 2 by 3. So 2 raised to 2 by 3, we can write it as 2 raised to 2 into 1 by 3. That is equal to 2 raised to 2 whole raised to 1 by 3. This way you can write, or you can write it as 2 raised to 1 by 3 whole square. Both way you are able to write. So in the first case, if it is like that, it will be in the form of a raised to 1 by n form. A raised to 1 by n is equal to nth root of a. So this we can write it as cube root of 2 square. Or you can write this also, it will 2 raised to 1 by 3, that is in the form of a raised to 1 by n. You know a raised to 1 by n is equal to nth root of a. So 2 raised to 1 by 3, we can write it as cube root of 2. So cube root of 2 whole square. So 2 raised to 2 by 3, we can write it in both way. We can write cube root of 2 square, or we can write cube root of 2 whole square. Both way you are able to write. So from these all examples, we understood that let A be a real number and M and N are integers, positive integers. Then A raised to M by N is equal to nth root of A raised to M, or that's also equal to nth root of A whole raised to M. We can write this in both ways. A raised to M by N is equal to nth root of A raised to M, or nth root of A whole raised to M. Because A raised to M by N, we can write it as A raised to M into 1 by N. A raised to M, it will be in the form of A raised to M into N. That means we can write A raised to M whole raised to N. So both way you are able to write. So we are getting a new identity or new law of exponent. A raised to M by N is equal to nth root of A raised to M, which is also equal to nth root of A whole raised to M. Let A greater than 0 be a real number and M and N are integers, and N and M have no common factor other than 1, and N is greater than 0. N greater than 0, then A raised to M by N is equal to nth root of A whole raised to M, which is also equal to nth root of A raised to M. We now have the following extended laws of exponents. Let A be a real number, A greater than 0 be a real number, and P and Q are rational numbers. P and Q are rational numbers. Then the following laws are extended. A raised to P into A raised to Q is equal to A raised to P plus Q. We extended that exponent to rational number, so the laws of exponents will be let A be a real number, that is A greater than 0, and P and Q are rational numbers. Then A raised to P into A raised to Q is equal to A raised to P plus Q. A raised to P divided by A raised to Q is equal to A raised to P minus Q. And A raised to P whole raised to Q is equal to A raised to P into Q. In the same way, A raised to P into B raised to P is equal to AB whole raised to P. So that we extend the laws of exponents to the rational numbers. Let us do some problems. Find 64 raised to 1 by 3. We can write this 64 raised to 1 by 3 as cube root of 64, because we are using the law A raised to 1 by N is equal to nth root of A. Using this, we can write cube root of 64. Cube root of 64 is equal to 4. Or you can do the same problem, 64 raised to 1 by 3, we can write it as, we know that 64 is the cube of 4. 4 cube is equal to 64. So we can, 64 we can write it as 4 cube whole raised to 1 by 3, which is equal to 4 raised to 3 into 1 by 3. 3 and 3 cancel, that is equal to 4. Here we use the law A raised to M whole raised to N is equal to A raised to M into N. Both way you can do it. We can directly use this because we know this a raised to 1 by n is equal to nth root of a. You can directly use this formula, or what we studied in earlier classes, that laws of exponents we can apply here. In both way you are able to do. Let us see the next question. 125 whole raised to minus 1 by 3. 125 whole raised to minus 1 by 3. We know that a raised to minus m is equal to 1 by a raised to m. So first of all, you have to change this negative, change it to positive. So you have to apply this formula. Then it will be 1 by 125 whole raised to 1 by 3. Now this is in the form of a raised to minus m. Here the value of m is equal to 1 by 3. A raised to minus m, we can write it as 1 by a raised to m. So it will be equal to 1 by 125 whole raised to 1 by 3, which is equal to 1 by 125, we can write it as 5 cube. 5 cube whole raised to 1 by 3, which is equal to 1 by a raised to m whole raised to n is equal to a raised to m into n. 3 into 1 by 3, 3 and 3 cancel, the answer is 1 by 5. Or directly you can this formula, that is equal to, so this will be equal to 1 by cube root of 125, which is equal to 1 by 5. In both ways you can do it. The next question is 27 whole raised to minus 2 by 3. It will be in the form of a raised to minus m, which is equal to 1 by a raised to m. First we have to use this law. Then it will be equal to 1 by 27 whole raised to 2 by 3. We got the positive exponent. Now you can use the laws of exponents, that is 1 by 27, we can write it as 3 cube whole raised to 2 by 3, which is equal to 1 by 3 raised to 3 into 2 by 3. 3 and 3 cancel, so it will be equal to 1 by 3 square, that is equal to 1 by 9. Or you can write this 1 by 27 whole raised to 2 by 3 is equal to 1 by a raised to m by n is equal to, we know the law, a raised to m by n is equal to nth root of a raised to m. Or you can write nth root of a whole raised to m. Both way you can write. So if you are applying this law here, then it will be 27 whole raised to 2 by 3. We can write it as cube root of 27 whole square, which is equal to 1 by cube root of 27 is 3. 3 whole square, that is equal to 1 by 9. So you can answer in both ways. Which is convenient for you, that you can opt. See the next question. 64 by 25 whole raised to minus 3 by 2. This is in the form of a by b whole raised to minus m. A by b whole raised to minus m, we can write it as b by a whole raised to m. So if you are using this law here, it will be 25 a by b, we can write it as b by a. 25 by 64 whole raised to 3 by 2. Now you can apply a raised to m by n is equal to nth root of a whole raised to m. So here it will be equal to square root of 25 whole raised to 3, or you can each one you can write together. Square root of 25 by 64 whole raised to 3, because this will be equal to 25 by 64 whole raised to 3 into 1 by 2. So that we rearranged using this laws of exponents. So square root of 25 by 64 whole raised to n, because a raised to 1 by n we can write it as nth root of a. So here 25 by 64 whole raised to 1 by 2 we write it as square root of 25 by 64 whole cube, which is equal to square root of 25 by 64 is, square root of 25 is 5, and square root of 64 is 8. So it will be 5 by 8 whole cube. That is equal to 125 by 8 cube is equal to 64 into 8. 8 fours are 32. 3 is remaining. 6 fours are 48. 48 plus 3. 51. So the answer is 125 by 512. See the next question. Simplify 64 divided by 125 all raised to minus 2 by 3. So first of all we can write this as a by b whole raised to minus m is equal to b by a whole raised to m. Now we can see 2 by 3, a raised to m by n is equal to, a raised to m by n is equal to nth root of a whole raised to m. So we can write this as cube root of, here it is 1 by 3, so cube root of 125 by 64 whole raised to 2. Which is equal to cube root of 125 is 5. 5 cube is 125. Cube root of 64 is equal to 4. 4 cube is equal to 64. So 5 by 4 whole square, which is equal to 5 square is equal to a by b whole square is equal to, or a by b whole raised to m is equal to a raised to m divided by b raised to m. So here 5 square is 25 divided by 4 square is 16. So the answer is 25 by 16. You can use the other method also. You can use the laws of exponents what we have studied earlier. If you are using that 125 we can write it as 5 cube. 64 we can write it as 4 cube. So 5 cube by 4 cube whole raised to 2 by 3. Then use the law a raised to m whole raised to n equal to a raised to m into n. Using that you can solve, you will get the answer 25 by 16. Both way you can do it. So practice this type of questions in both methods, which is convenient for you, that you can opt. If you are very easily you are able to do using this law, you can practice this way. Otherwise you can practice with the laws what we studied in earlier classes. So dear students, you have to revise this laws of exponents, write and study this laws of exponents, and practice the questions what we discussed in the section. After that, you have to do your worksheet. Today's your worksheet is simplify each of the following. 3 questions are there, including exercise 1.6. These 3 questions plus exercise 1.6. So, first you study the laws of exponents, write and study the questions what we have studied in the class, discussed in the class, then do your worksheet. You should do this worksheet in your notebook itself. When you are writing notes, you should write the heading Laws of Exponents for Real Numbers. And you should read textbook page number 25 and 26 and prepare your own note. The answer key also I given here. You can verify your answer after doing these problems. The final answer only I given. After writing all solution, you can check your answer.